G'day, Alucard J here. Now, I just finished recording a video showing how to apply the Perlin module and some filters to generate some more complex noise. It turned out to be a very long video. I made a few mistakes and it probably isn't that exciting to sit through. So I thought I'd do the same thing as I did for the filters video because I didn't want to write out the whole script again and just present what's going on in the script and then have a look at how you can make some of this noise for yourself. So I created this script. Let's start off by explaining what these quads are. So we have these two quads here, and this is our noise sample 1. So in this first noise sample, we're going to be generating our Perlin module noise and outputting it as a texture onto this. And then we apply a filter, and then we get the after the filter has been applied to that noise. So this is a before and after filter of noise 1. And then we have these two quads here for another noise sample, noise 2. And then this big quad at the end here is blending these two outputs together to create a final noise map. So let's have a look at what's happening here. So as I said, in our noise, we have all the parameters that we use in our Perlin module to give these different outputs, and then we apply that to our quad before. And then we run it through a filter. And then some of our filters have parameters, like our exponential filter has these parameters here, and our flatten and smoothing filters have this iterations parameter here. So after we run it through our filter, we have our quad after, and then we put in our output. Okay? And we have the same for our second noise. And then finally, we have our quad output here where we take in the noise array from this one, the after the filter, and the array of noise here after the filter, and we blend them together. And then we apply them to this quad to see what we get. Now, I was also playing around and couldn't really come up with some great examples of noise. But let's see what we can do here now. So for example, I brought that one right up. See, we're creating a very noisy map here. We could apply one of our filters to it. See, we're getting different kind of filters, and we're also seeing our output is blending these two together. So if we turn this one without flatten, too much. Then we have our bias here. I also changed the bias around because it's a bit counterintuitive. Like if you push it to the left, you'd want more of noise 1. And if you push it to the right, you want more of noise 2. So I changed that around. So let's have a look. What if we create a high frequency of noise? Change the offset to this one. And create a low frequency of noise and then add the two together. Okay, you see we start to get different outputs. Like you've got this smoothness of this one here, but the added noise of this one here. Okay, and similarly, if we turn this down, we could turn this one into a mask with the exponential filter and use a blend multiply, and so we create some sort of islands. So let's turn the frequency up on this one a bit. It doesn't look much in grayscale, and my color gradient's set too high for the water to really show an output. So the best way to see an output is if we apply this to a terrain. So I'm going to go ahead and make another video where we finally get this generated noise and put it onto a terrain. Just looking at that script that I made. Here we have an enum for all our single filters and an enum for our blend filter. Here's our class that stores all our noise variables for each noise sample. two noise samples, and then our blended quad with the blend filter, the bias, that parameter for the blend add. We have a function here. We'll take a noise sample rather than type them out both the same for each noise sample. Just pass the noise sample in, create Perlin module, get our before noise, apply the before noise to the renderer, run the noise through the filter, and then that noise again that's been filtered, we put it on our after texture, our after renderer. And the output, we just get we create a new array to store this. We'll use our filter to add the two noises together and apply it to the renderer. So this is a short version. Next I'm going to go ahead and, because this is more of a tool than something that you'd use in game. I mean, you could use this for procedurally generated content, but this is more of a tool designing terrains in the editor, and we want to apply this noise to a terrain. So I'm going to create a custom editor script where you can just click a button here without it being in play mode, and it will automatically generate these textures and these noise maps for you. And the other beauty of that is if you're in play mode and then you hit stop, you lose all those values. But if we're in edit mode and we change these values, then they're not lost. So let's do that video.